let's have a look. The cost of running a car at an average speed of v kilometers per hour is given by that cents per hour. Find the average speed at which the cost of the minimum. So for this question, it's really quite simple, right? Whenever you're looking for a minimum, we want when the first derivative
is equal to 0.
Yep, hold on, let me just rub this out, okay? So we're looking for when the first derivative, which is c dash, is equal to 0, and c double dash is?
Greater than 0.
Yeah, positive. Got it? Does that make sense?
Yeah.
Yeah, that's essentially what we're doing, right? We're looking for when the first derivative is equal to 0 and when the second derivative is greater than 0. So let's do that. So c dash equals to what?
2v. Hold on, actually.
Yep, 2v on 75.
Yeah.
Yep, and we want when that's equal to 0. Yep.
So v equals 0.
So v equals to 0. And the cost of running a car at an average speed of... Oh, per hour. Okay, that's per hour. All right, that's the cost per hour. Okay. So, the real cost is not that. Okay. The real cost is 100 plus v squared on 75. That's the cost per hour times 1,000 over v. Does that make sense? Because that's how many hours it will take to travel 1,000 kilometers.
Yeah.
Does that make sense? So that's the cost per hour, and that's how many hours it will take. So the real cost is that times that. Yep.
Yep.
So you really end up with c equals to 100,000 over v plus 1,000 over 75 v. Does that make sense? That times that equals 1,000 over v. That,
yeah.
Yep. Got it?
Yep.
Once we've got that, then we work out c dash, right? Which is v to the minus 1, so it's minus 1 v to the minus 2.
Yep.
Plus, yep, okay, because the v will disappear when we differentiate, equals to 0, okay, which equals to, right, negative, oh, hang on, let me just rub this out. Now I'm going to bring all of this bit over to the right hand side, which gives us 1,000 over 75 equals to over v squared. Got it?
Yep.
Then we solve for v, all right? V squared equals to, does that make sense? Yep.
Yep.
So we're solving for v squared. That cancels with that, leaving us with 7,500 v squared v has to be equal to the square root of that, which is, let's see, 50 root 3 will be the answer.
Yeah.
Good. Okay. Now, the last thing we have to do, right, is we basically have to test the second derivative as well and make sure the second derivative is positive.
Yeah.
And then that's basically your answer. Okay? Yeah. Now, the second derivative will be positive because you've got c dash equaling minus 100,000 on v squared plus 1,000 on 75. That's going to disappear. When you differentiate that, your power has got to be negative. Negative times a negative is positive, right? So your overall answer is going to be positive, right? So c double dash is going to be greater than 0. So it is a minimum. Okay. Now, in terms of maximum minimum questions, right? These sort of maximum minimum questions, like where you apply it to real life examples.
Yeah.
If you don't get it in 1 week, don't worry. These things takes ages to get, right? And just to give you some reassurance, these sort of questions are basically going to be the kind of like the last question in most papers. It'll be like your question 15 and question 16 in the 2-unit paper. There's going to be like the very last question. Okay. These get really difficult, right? And these are the sort of questions that they basically save for the end for the really smart, for the really smart ones. Yep.
Okay.
So if you don't get it now, don't worry, all right? But what we'll do is we'll come back, revisit it, right? And you'll get the hang of it eventually.
Yep.
Okay?
Okay. Thank you.
No worries, Rebecca.